So we have implemented all the CRUD operations, but there is a small issue in our current implementation. Note that when I click the delete button, it takes about a second until this post is removed from our table. Have a look. Delete. It took about half a second or a second. It wasn't immediate. We have the same issue when updating a post or adding a new post. There is a delay until we see the result. And here's the reason. The reason is that in our current implementation, we're always calling the server first, and then we're updating the view or the UI. With this implementation, if an error occurs while calling the server, the rest of this function will not be executed. This is what we call pessimistic update. So we are not sure if the call to the server is going to succeed or fail. In contrast to pessimistic update, we have optimistic update. So we can assume that most of the time, the call to the server succeeds. So instead of calling the server first, which is going to take some time, we're going to go ahead and update the UI, and then we will call the server. Now, if this call fails, we can revert the UI back to its previous state. Let me show you how to implement this. So first, I'm going to move these two lines up. So we're going to update the UI first and then call the server. Save the changes back in the browser. Now, when I click the delete button, this post will be immediately removed. Have a look. Delete, delete, delete. So even though the call to the server still takes about a second, this implementation gives the user the illusion of a fast application. But we are not done yet. So what happens if something goes wrong? We need to undo the most recent change. In React, this is pretty easy because we never update the state directly, so we can always have a reference to the previous state. So here on the top, I'm going to define a constant, call it original posts, and set it to this.state.posts. Now, if this call to the server fails, we're going to call this.setState and pass our original posts. This will easily revert our UI back to the previous state. So, in order to detect errors, we need to wrap this call with a try-catch block. So, try, put this line here, and then catch. In catch, we get an exception or an error, and this is the moment when we display an error to the user and revert the screen. So we can display an alert like something failed while deleting a post. And then we call this .setState, set our posts to original posts. As simple as that. Now let's simulate an error. So right after the call to axios.delete, I'm going to throw an error. This is just a simulation because our fake backend JSON placeholder is always up and running. So it's hard to simulate a real error unless I disable my Wi-Fi so there is no internet connection. But I can do that for several reasons. So that's why I'm throwing an error. So let's test the application. Back in the browser. Note that when I click the delete button, this post will immediately disappear. And then after about a second, we're going to see an alert telling us that something failed. And then this post will come back to the table. Have a look. Delete, it's gone. We got the alert, something failed. Okay, and the post is back. So this is how you implement optimistic updates. First, you keep a reference to the original state. Then you update the UI before calling the server, and then wrap the call to the server in a try-catch block. In the catch block, you'll display an error and then update the state to the previous state.